Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. I.P.S. Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with the orthographic projections of a solid in which the front view and the top view of the solid they have been provided to us, and we are required to draw the isometric projections of the solid from the given orthographic views over there. Now we can check this construction whenever we are required to draw the isometric projections. So the three faces, that is the front view face, the top view face and the left hand side view face, all these three faces will be projected in a single 3D isometric projection. Now we are going to draw the left side view of the solid on the XY plane, and the front view of the solid will be drawn along the YZ plane over here. Now let us evaluate the dimensions of the front face, top face and the side face of the solid. So looking at this construction from the front view, we find that the length of the solid happens to be 75 millimeter, while the height of the solid it is equal to 48 millimeter. So the front view face will be measuring 75 millimeter by 48 millimeter. So here we can see the front view we have drawn along the YZ axis over there. So this is the Z isometric axis and this is the Y isometric axis. So along the Y isometric axis we have drawn the height of the solid equal to 48, and along the Z isometric axis we have drawn the length of the solid which is equal to 75 millimeter. Now looking at the solid from the top, so we are getting the length of the solid, it is equal to 75 millimeter, and the width of the solid happens to be 100 millimeter. So this top view face will be drawn along the XZ axis. So we can check along the XZ axis we have plotted the 100 millimeter of the width of the solid along the X axis, and the 75 millimeter length of the solid has been plotted along the Z axis. So this will give us the construction of the base or the top face of the solid. Now when we talk about the side face of the solid, so in the side face we are going to get the width of the solid, it is equal to 100 millimeter, and the height of the solid it is equal to 48 millimeter. So the side face will be having the dimensions 100 millimeter by 48 millimeter. So this side face we have drawn along the XY axis over here. So along the x-axis we have plotted 100 millimeter width of the solid, and along the y-axis we have plotted the height of the solid equal to 48 millimeter. So we know that along the z-axis the length has been plotted, along the y-axis the height of the solid has been plotted, and along the x isometric axis we have plotted the width of the solid. So this side is going to represent the left side view of the solid, whereas this face or this side it is going to represent the front view of the solid. Right? Now let us first of all study the given description of the geometric shape of this component. So as we look at this particular solid, we find that there are three steps which are involved in this particular solid, and since we have the total height of the solid equal to 48 millimeter, so all these three steps they are having equal height, that is equal to 16 millimeter, and the height is also equal for the three steps, whereas the length of each step this is also equal, which is equal to 25 millimeter. Right? So this is the construction of the three steps. So in the three steps we are going to get the length, it is equal to 25 millimeter, then you have the height, it is equal to 16 millimeter, then again 25 millimeter, it is the length of the second step, and 60 millimeter it is the height, And then for the third step, 25 millimeter, it is the length of the step, and 16 millimeter, it is the height of the step over there, step number 1. Now, besides these 3 steps, once we look at the solid from the top, so there is a horizontal web over here which is lying at the top surface. So this is one horizontally faced web over here. So this is a flat web which will be lying on this part of the solid, that is on the rear side of the solid. Now what are the dimensions of this web? Now along this width of the solid, you have got the total length for the first part over here. The length of the web over here, it is equal to 25 millimeter. So as you move along towards from the front side to the rear side of the solid, the web is going to turn left over here. So as the web turns towards the left, so this, you see, width over here, so this width increases to 36 millimeter, right? So this web starts with 25 millimeter length over here. So this is the thickness which is occurring from the top view. This is equal to 25 millimeter. So as this web turns towards the left side, so this width, it is equal to 36 millimeter. So this cross section is not uniform. It is an uneven cross section. That is, from the front face over here, it starts as having the length or the thickness equal to 25 millimeter. As it turns towards the left side, now you are going to get the width of this web equal to 36 millimeter. And then since the total width of the solid is 100, so the 3 steps which we are going to have, they are going to have width equal to 64 millimeter. So this is the basic discussion about the geometry of the component. Now let us start with development of the isometric projections of the solid. So first thing, we are required to draw the isometric scale, and all the dimensions which are available in these orthographic views, they will be first of all plotted onto the true length or the true scale over here, and the corresponding isometric lengths, they will be evaluated corresponding to all the dimensions which are appearing in front view or the top view of the solid. And once we have obtained the isometric lengths corresponding to these true lengths, so these isometric lengths will be used to draw the isometric projection. So step number 1, we have got this horizontal datum line over here. So this is our horizontal ground line, and onto the horizontal ground line we are going to mark an origin point. So this is our origin point. So from the origin point towards the left side, we are going to draw the isometric x-axis over here. This is the isometric x-axis towards the left side, which is drawn at an angle of 30 degree. Similarly, from the origin, we are going to draw the isometric z-axis, which will be drawn towards right at an angle of 30 degree. And from this origin, we are going to draw the vertical axis over here, and the name of this axis is y-axis, right? So this is called y-axis. So y-axis is going to represent the height of the solid, and as we have discussed, along the z-axis we are going to mark the length of the solid, which happens to be 75 millimeter. So let us draw the front face of the solid. So the front face, please check the size of the front face dimensions. It is equal to 75 millimeter length and 48 millimeter is the height. So we have drawn 75 millimeter length and 48 millimeter height over there. So our front face has been completed. So in order to complete the front face, another isometric line is drawn parallel to the z-axis, and this edge will be equal to 75 millimeter. Similarly, another vertical edge, which is an isometric line, will be drawn parallel to the y-axis, and the measurement of this edge will be again equal to 48 millimeter over there, right? So this way the front view face of the solid has been completed. Next, we are going to draw the left side view of the solid. In order to draw the left side view, we know the width of the solid. The width of the solid happens to be 100 millimeter. So this is 100 millimeter width of the solid. Now height of the solid, we already know this is equal to 48 millimeter. And now we can complete the left hand side face of this particular solid. So in order to complete the left side face, so another isometric line parallel to the x-axis we have drawn, measuring 100 millimeter. Another isometric line parallel to the y-axis we have drawn, which will be measuring 48 millimeter. And now let us complete the top face of the solid. We know that the top face of the solid will be measuring 75 millimeter by 100 millimeter. So 75 millimeter we have drawn here along the z-axis. So this is also 75 millimeter. Now we are going to draw another isometric line which will be parallel to the z-axis, and this isometric line will be measuring 75 millimeter. And finally another isometric line over here will be drawn parallel to the x-axis, and this will be measuring 100 millimeter. So after completing the top face, now we need to complete the bottom face of this rectangular prism basically. So this solid will be a rectangular prism within which all the elements of the solid will be located appropriately. So in order to complete this bottom face, so once again another isometric H which will be parallel to the z-axis has been drawn, and one more isometric H parallel to the y-axis has been drawn, measuring dimension equal to 48 millimeter. And finally this isometric H will be drawn parallel to the x-axis, and this will be measuring 100 millimeter. So this way we can see that a rectangular prism, this is a rectangle and this is a prism over here. So a rectangular prism has been located, and within this rectangular prism we are going to locate different parts of this particular solid whose orthographic projection they have been provided to us. So this is the front view, this is the top view of the solid. Now in the front view we can see that there is a length of 25 millimeter corresponding to step 3, then the height is 16 millimeter, and again for the second step the length is 25 millimeter, again the height is 16, and corresponding to the first step over here you have got height 16 millimeter and the length is 25 millimeter. Now since there are 3 steps, so I am going to draw 2 rings over here which are having the heights equal to 16 millimeter from the bottom. So this 16 millimeter will be their height corresponding to the first step. Another 16 millimeter height we are going to take corresponding to the second step. So please see, I am going to draw the first ring over here. So this ring will be passing through all the sides of this particular rectangular prism, and this ring has been constructed at a height of 16 millimeter from the bottom over here. So here the first part of the step number 1 will be located. Now in order to locate the second part of the step number 2 over here, this is my step number 2, which is again measuring height 16 and the length is equal to 25. So a second ring will be constructed over here which will be having a height of 32 millimeter from the base or 16 millimeter from the top of the step number 1 over here, right? So this is the top of the step number 1. Either you say it is 16 millimeter above the step number 1 or it is 32 millimeters from the base. So let us complete the second ring over here. So once we have completed these 2 rings, now I need to start this particular web over here. So it is a flat web as it appears to us from the top, and in the front also we can see this is a flat web which is having a height of 48 millimeter. So this is a web which is having a height of 48 millimeter. So this is the height of 48 millimeter. That is this web which is L-shaped web over here. This will be lying on the top surface. So on the top surface what I am going to do, I will be marking 25 millimeter distance from this particular face over here, 25 this way, and I will be marking 36 millimeter. This is going to be my width over here. This is 36 millimeter will be my width measured from the rear face of this particular solid. So this distance we can see it is equal to 36 millimeter. So this is the width, and this is 25 millimeter is the length over here. So 25 millimeter length now I am going to mark. So please check, I have marked the length equal to 25 millimeter from the back face over here. Now once I have marked this 25, so another 25 will give me this portion of the step number 2. So this is step number 1. This will give me step number 2, this point, right? And finally another 25 will give me the front face over here, that is this corner of step number 1. So these 3 steps I have appropriately located onto the top face, and corresponding to the step 1 we are going to draw a horizontal line, and corresponding to this width of 36 millimeter, this is the width of 36 millimeter, now we are going to draw another projection line over here, so that now I can see once I have drawn both of these projection lines, so this L-shaped surface has been obtained over here. And the characteristic of this L-shaped surface is that on this side the length is equal to 25 millimeter, that is from the front view side. So from the front view side, this is the length, it is equal to 25 millimeter. So while it moves towards the left side, so this width becomes 36 millimeter. So this width, it becomes 36 millimeter. So this face, that is the flat face of the L-shaped wave which is located at the top of the solid, has been appropriately marked. Now having marked this wave, now the next thing is I have to work out these 3 steps over there. So 3 steps I need to work out. So 25 millimeter from this back end distance I have marked, it is equal to this distance. So please check, this distance is equal to 25 millimeter. Similarly this distance, it is also equal to 25. So the flat surface of the step number 3, it has been obtained in the isometric projection. It is this surface. Now from this point, that is this point, and from this point I need to move downwards with a height of 16 millimeter over here. That is, I have to descend by 16 millimeter from this particular corner. So from here I will be moving down perpendicular equal to distance which will be 16 millimeter. So please check, this is a distance of 16 millimeter, and once I move 16 millimeter down, I will be ending up at the ring number 2 over here. I will be ending up at the ring number 2. So over here it ends directly on ring number 2. Here it is the interior portion. So here I will not be ending on the ring number 2, it will be ending on the inner portion of this particular ring surface. Now I will be joining another isometric line parallel to this line over here, so that this flat surface, please check, this flat surface or this corner, so this corner H which is available as a flat surface over here, this can be obtained. So this is the vertical face of step number 3 which has been obtained, and this lies on the top face of the ring number 2 over here. So having reached this point, another thing we have done, we have brought a vertical component of this web. So this was a vertical web over here. So this web has been produced downwards, so that this becomes my flat portion of the web over here. So it will be moving down over here. Where will it end? It will be ending at the top portion of the first web over here. It will be meeting at this particular point. So that is why this vertical wall is there. So this vertical wall has been drawn over here. This is my vertical wall. Okay. So now this face is completed now, and this step is also completed. Now in order to draw the second step, what I need to do, from this side, from the rear end, this is my front side. So here from the rear side I have to move towards the front face by another 25 millimeter. So from here move forward by another 25 millimeter. From this corner move forward by another 25 millimeter. So please check, move forward by 25, move forward by 25, and join this particular, these 2 points over here. So once you join these 2 points, so this flat surface, it will be obtained over here. And once you have reached this point, so this edge from the top view has been obtained by us. So this edge corresponding to the step number 2 has been obtained. But right now we have been able to obtain this point. I need to obtain the bottom point also. So in order to obtain the bottom point, I know that the height of the second step, it is also equal to 16 millimeter. This is the height of the second step. So what I need to do from this point and from this point, I will be moving down another 16 millimeter. So once I move down another 16 millimeter, I will be ending up at the top surface of the ring number 1. I will be ending up at the top surface of the ring number 1, which is located at a height of 16 millimeter from the base of the solid. It is located at a height of 16 millimeter from the base of the solid. Now this horizontal edge I need to locate. So this horizontal edge I will be able to find out once I join this point with this point. The moment I join these 2 points, so my vertical wall of step number 2 has been drawn over here. This is the vertical wall of step number 2 has been drawn. So this is the vertical wall of step number 2. So from the top view, it will be this line and this edge, they will be coinciding as a single edge over here. Then in order to obtain the first step, move 25 millimeter towards the front face. So you move 25 millimeter towards the front face. So once you are moving 25 millimeter towards the front face, so this particular edge will be located, and once you darken this edge, so this point will be located over here. The moment you locate this point, so this and this particular points you need to join. So step number 1 has been located, step number 2 has been located, and step number 3 has been located. And besides this, this angular flange or the web, it has also been drawn onto this isometric projection. So all the edges of this solid, they have been drawn in the isometric projection. Now I am going to go about darkening of the edges which are visible to the observer. From the left hand side view, the observer will be able to see this face, and then this one will give you the L-shaped front cross section of the solid, and then you join this one, and then the 3 steps we are going to draw. So this is the base and this is the top web over here, which is having unequal thickness. So this portion of the top web, it is having the thickness equal to 25 millimeter, and this portion of the web, it is going to have the thickness which is higher thickness, or the width, it is equal to 36 millimeter. And now once we join this, now the next thing is we have to complete step number 3. So this is the completion of the step number 3, and then you move 25 millimeter forward, move 25 millimeter forward and join this particular edge. So the flat portion of the second step has been appropriately located in the isometric projection, and again you move down to complete the step number 2. This is the height of the step number 2. So this is the vertical face of the step number 2, and then you move another 25 millimeter forward to complete the step number 3. So this is the complete construction of the isometric projections of the solid, wherein the orthographic views, that is the front view and the top view. So this was the front view and this is the top view of the solid which were provided to us. So I hope that with this discussion you would have understood how do we proceed regarding the construction of the isometric projections once the orthographic projections of the solid, they are available with us. So this is all for today. So we'll be continuing with further discussion on few more cases of the isometric projections in the coming lectures. So thank you very much. Thanks a lot.